In today's lesson, we are going to work with complex numbers and the Cartesian form of the complex numbers and various operations on complex numbers. So the standard form of a complex number is z or z is equal to a plus iota b. A and b belongs to R, and iota is the iota square is equal to -1 is a complex numbers, or iota is equal to square root of -1. So whenever you have an equation x squared plus 4 equal to 0, where you get x squared is equal to -4, then we don't have any real solution here, but we do have a complex solution. So we can write this as 4 iota square, and then x is equal to plus minus 2 iota will be a solution of this quadratic function. So, and then we can also represent complex numbers on our Argan diagram, and the Argan diagram is the x-axis is the real part of the complex number and y-axis is the imaginary part of a complex number. So if you have z which is equal to a plus iota b, then real part of z is a and imaginary part of z is b. Okay, so now here if I have let's say 2 plus 3 iota, so we plot them, the coordinates will be 2, 3. So 2 is the real one, will be plotted on x-axis, and 3 will be plotted on y-axis. Now we need to find the real and imaginary part of 2 plus 3 iota. So the real, let's say this is equal to z, so real z is equal to 2 and imaginary z is equal to 3. So pay attention that the imaginary part, you do not write the imaginary part with iota, the iota has to be excluded from the imaginary part. Here real z and imaginary z, this is z is equal to, this is 2, this is -5, and this is wrong, and the reason is that because this is not given in the form it should have been, because first whenever you write a complex number, the real part should come first and then the imaginary one. So we need to rewrite this. So this is -5 plus 2 iota. So real z is equal to -5 and imaginary z is equal to 2. Okay, so be careful when you have a complex number which is not given in the standard form, and the standard form is you should always have real first and then iota b. Okay, then the imaginary part. So here 2 over 3 minus 7 iota. So real z, if this is z, real z is 2 over 3 and the imaginary part of this is -7. Okay, why -7? Again, because in the standard form we have a plus iota b. So here let's separate them first. So this is equal to, this is also 11 over 4 iota. So your real part in this case is 11 square root of 11 over 4, and imaginary part is 11 over 4. Okay, then the next one is the modulus of a complex number, and the modulus of a complex number is when we have 2 plus 3 iota, and when I plotted this, so the point which we got here is corresponding to 2 plus 3 iota was this one, 2, 3, and then when we connect this with 0, this gives the modulus, which is the hypotenuse of a right angle triangle. So the modulus is simply 2 square plus 3 square and then square root of that. So in this case, when you have a plus iota b, the modulus is equal to square root of a square plus b square, or you can say it's a square of real part of a complex number and square of imaginary part of the complex number, and then you take the square root of that. Now we are going to do the modulus of few questions, and then we'll check using GDC. So we'll also learn how to use GDC to find the modulus here. So here the modulus will be 5 square plus -12 whole square, and then you take the square root. This is 25, 144. So you get 13. Modulus is always positive. Okay. Now here you do the same thing, 1 over 2 whole square plus -1 over 4 whole square, and then you take the square root. So 1 over 4 plus 1 over 16, and then this will become 5 over 16, square root of that. So square root of 5 divided by 4. Now here same thing, I will not do this is the imaginary part. I will not do all the calculations here. So this is real z, which is -21 over 29. So -21 over 29 whole square plus 20 over 29 whole square, and then you take the square root of that. Now I'm going to show you how to use GDC. So for GDC, to find the modulus, you go to math and then you have COMPLX, which is complex, and you can use that feature to find even the conjugate. The conjugate is simply when you have a complex number which is z a plus b iota, then z star is equal to a minus b iota. So this is called, z star is called the conjugate here. We'll talk about this in other videos. So now if I have to find the modulus in calculator, it does not use the word modulus, it uses the word absolute. So ABS, and now we need to enter. The first one I'm going to enter is 5 minus 12, and then iota is, you press on second dot and then you get your answer is 13, which we also got by hand. Now similarly you can do the next one, 1 over 2 minus iota over 4. So I'm again going to show you how to do that. So you go to complex, go to number 5, which is absolute. These are the instructions for TI-84. The instructions will be different for different calculators. So here we need to do is half minus, so I'm going to use the alpha feature here. So 1 divided by 2 minus alpha y again, and then 1 divide by 4, and then I need iota here, so second dot, and then we enter. So we get 0.559, and without using calculator we got the answer which was in the exact form. So I'm going to check it here. So alpha y, and then you have second square root of 5, and then divide by 4. Let's see, we also got the same answer, so which is exactly the same as this one. So this is how we use the calculator. Now the next one which we need to do is operation with the complex numbers. So I'm just going to do one example on subtracting and adding. So when you subtract two complex numbers, z1 minus z2 in this case, so 4 minus 3 iota, negative 2 plus 5 iota. So the way we subtract them is, we subtract real from real, subtract or add. So you subtract or add real from real and imaginary from imaginary. So just like in algebra, collecting like terms. So collecting like terms is the way to add or subtract the complex number. So in this case it will be 4 minus 3 iota, negative plus 2 minus 5 iota, and then you get 4 plus 2, which is 6, minus 8 iota. Similarly for 1 over 3 z1 plus 2 over 5 z2. So first I need to find is 1 over 3 of z1, and then 2/5 of z2, which is negative 2 plus 5 iota. And if I open it, this is 4 over 3 minus iota minus 4 over 5 plus 2 iota. And now we are going to collect like terms here. So 4 over 3 minus 4 over 5, and then you have plus iota here. So this one is equal to 15. 20 minus 12 plus iota. So you got 8 over 15 plus iota. Okay, now we can also use calculator. I'm going to use calculator for the first one to see that whether our answer is correct or not. Now to do addition and subtraction or multiplication or any other operation with complex number, we don't have to use the feature math. We don't use it, math complex number. We just use the screen here, and then you enter 4 minus 3 iota, and then you need to subtract. So subtract negative 2. Whenever you enter negative numbers, you have to use this key. So negative 2 plus 5 iota, which is second iota, and then you enter it. So you got 6 minus 8 iota, which is exactly the same. It's exactly the same as I got it by hand. So that's it for today's video. Thank you.